The circle C has centre A and radius R. The points P, 3 minus 8, and Q, 5, 6, are at either end of a diameter of C. Write down the coordinates of A. Show that R is root 50. Write down the equation of C. Verify that the point R, 9 minus 6, lies on C. And find the angle PQR. So here's the question in summary form then. Let's have a little look at it. Okay, so we've got this circle, centre A. Write down the coordinates of A. So part A then, the coordinates of A is the midpoint of the diameter, isn't it? So the midpoint, 3 plus 5 is 8. 8 divided by 2 is 4. Minus 8 plus 6 is minus 2. Divide that by 2 is minus 1. So there's our centre coordinates A. Show that the radius, so part 2, the radius is equal to half the diameter, and the diameter will be the distance between these 2 points using Pythag. Difference between the x is 2, so we can square that value. The difference between the y's from minus 8 to 6 is 14, so we can square that. So as these two added together, both squared, and square rooted gives the hypotenuse of that triangle. 196 plus 4 is 200, so it's root 200 over 2. 450s, so it's root 4, which is 2, root 50 over 2, which equals root 50. So our radius is root 50. Write down the equation of C. So part 3, let's do that then. So we've got x for the circle minus the x value at the centre, 4 squared, plus y minus the y value is minus 1, so that's plus 1, squared is equal to the radius squared, which is 50. And there's our equation of the circle C. Verify that the point 9 minus 6 lies on C, so this is B here. Put 9 in then, 9 minus 4 squared plus minus 6 in the y value plus 1 squared is 5 squared is 25 plus 5 squared is 25 equals 50. So yes, it does, because it equals 50, and that's the equation of the circle. So the R lies on C. Find the angle PQR. Okay, so we've got P and Q, and then R. So let's have a look at that. There's 3 coordinates in the triangle. 3 minus 8. So I'll put it here. There's P. 3 minus 8. Q is 5, 6, wasn't it? So let's put it over here. P is somewhere. There's Q. And they form the diameter of the circle. And the radius R, the point R is 9 minus 6. 9, put it here, minus 6 will be down here somewhere. This is R. 9 minus 6. This forms a diameter. This lies on the circle, doesn't it, this point here? So it follows, using the property of circles, that that must be 90 degrees. So what is this distance here, PQ? This is a 90-degree triangle. So we want the angle PQR, which is here. So if we do the opposite over the hypotenuse, the length of this is 2 root 50 diameter. So we could do the sine, couldn't we, just by working out this length here. So PR then, let's just work out that. Using Pythag, it's going to be the square root of the 2 sides squared. 3 and 9, the difference is 6. So it's 6 squared. Minus 8 to minus 6 is a difference of 2, so that would be 2 squared. So that's root 40. So this is root 40. So the sine of PQR is equal to the opposite, root 40, over the hypotenuse, 2 root 50. So that equals, so I'm going to carry on over here. This will be 4 over 5, won't it? Root 0.8 over 2. Could do it like that. Yeah, 0.8 square rooted this is. So it's the square root of 0.8 over 2. which is 2 is root 4, so 0.8 over 4 is 1/5, so it's the square root of 0.2. You can tap it in the calculator if you need to work out what this is as a decimal. So PQR then, shift sign of root 0.2. Let's do that then. We're in degrees mode, which we are, so shift sign of the square root of 0.2. Close bracket. Come out of the square root, close the bracket, equals 26.565 degrees.